So, welcome to this webinar dedicated to the Interreg Northwest Europe Hi-Ecowire project. This is a project dedicated to high-quality eco-efficient magnet wire. I will present you the program. So first, I will make a presentation of the competitiveness cluster NextMove. Then I will let Hamid and Mireille present, make a general presentation of the project, and we will have a technology focus at the end, made by Arnaud Nicolai from Essex. So I begin with the presentation of NextMove. NextMove is a competitiveness cluster. It's a French cluster. Our cluster is designed to support innovation and to promote collaborative research and development projects. We bring together companies, large and small, research laboratories, training institutions, and also regional authorities in a well-identified area. For us, it's the Paris region and Normandy, and on a targeted theme, the automotive and mobility. We help our members to integrate a dynamic industrial network to strengthen their technological potential. We help them also to find fundings for their projects. And of course, as we are a network, we help them to find partners and customers. We are organized with 4 major drivers dedicated to low environmental footprint mobility, to connected and autonomous mobility, new services and mobility solutions, and we have also a big driver dedicated to industrialization and operational excellence. We are at the heart of the French innovation ecosystem. We have a collaboration with French automotive industry, OEMs, suppliers, with other players in innovation, with, of course, European clusters and European institutions. For example, we are a member of the EGVIA, European Green Vehicle Initiative Association. And we help our members to participate in Horizon 2020 and now Horizon Europe projects. Our ambition is to build the French Mobility Valley, which is the historical cradle of automotive in France, where mobility of the future solutions are invented, developed, tested, industrialized, and recycled at the end of their life. We think that it's very important to have all the value chain of mobility from conception to end of life. Few words about our activity. We used to say that 70% of automotive research and development activities in France are located in our region. It means Paris region and Normandy. Since its creation, the cluster has helped 250 projects to be funded, which represent an investment in research and development activities of more than 1.2 billion euros. So it's quite consequent at the moment. We have more than 100 technological and business experts that are involved in our different committees, and they are there in order to help our members to develop their innovations. Here you can see some examples of our members. We have today more than 600 members. Of course, big industrial groups, in the field of automotive and mobility, like Renault, Stellantis, Valeo, Faurecia, Plastic Omnium, ST Microelectronics, etc. More than 200 startups and SMEs. Of course, also research centers and laboratories, and also local authorities and territories, which is very useful when we want to promote experimentations on territories. We are involved in several European projects. You can see some examples here. They are not all here. So projects dedicated to autonomous vehicle, to energy performance in industry, and to exchanges between different countries and different clusters dedicated to mobility. And of course, you can see the Hi-Ecowire project at the bottom of the slide. I will now present you a few elements regarding electrifications in the field of automotive. So by 2030, you can see that in the automotive industry, we predict that all automotives will be electrified. It can be fully electrified or partially electrified, but all electrified. That means that all vehicles will have an electric motor there will be an electric motors in all vehicles by 2030. So we are fully involved in the development of electric mobility. We have actions on electric motors, like in the Hi-Ecowire project, others on batteries. And we also have, at the moment, an important action in the French National Initiative for Power Electronics. We are, for example, in charge of coordination actions and research and development projects evaluation. We have at the moment more than 25 research and development projects dedicated to power. We are also preparing an European initiative to force a new important project of a common European interest to push a strong and competitive European industry. And we also try to discuss with other industries that could be concerned by power electronics, like, for example, aeronautics, railway, or charging stations. And what is our mission in the Hi-Ecowire project? As a network of innovative stakeholders in the automotive sector, we will be the link between the project and the automotive actors. And of course, we will actively contribute to the long-term effects of the project, especially working on the replication of the technology in the automotive area. Because the trend in the automotive industry is to move to wound motors. There is sometimes still some permanent magnet used in motors, but the trend is to use more and more wound motors because they are more reliable, less expensive, and they don't use strategic materials, which is something very important for our industry. So we will need high quality copper wires, and that's why we are very interested in the Hi-Ecowire project. This is the end of my presentation. If you have questions, don't hesitate to put it on the chat. And Hamid, I can let you continue with the presentation of the project.
Thank you so much, for the presentation. I will share from me the screen with you. Do you see the shared screen?
Yes.
Okay, thank you so much. So from me today, I will show to you the general presentation of the project of Hi-Ecowire. So we will start with the project scope and the objectives and output of the project. And we will show you the main steps that we put in the project to reach the target result. We will present to you the partners and also their role in the project. And also we will present to you the associates partners of the Hi-Ecowire project. And we will give you the opportunity to have question and interaction with after this part of the presentation. And of course, as Geoffroy said, we will finish the webinar with technology focus on sol gel technology. And also we will give you the opportunity for any question and answers for this part. So first we will start with the project scope of the project. So we are doing our project. So it's carried out within the framework of the Interreg project, or Interreg Northwest Europe project, which is a program of the European Union to promote the economic, environmental, social, and also territorial future in the Northwest Europe area. In this program, we have the program focus its priority on 3 different axes: innovation, low carbon, and also resources and material efficiency. So for Hi-Ecowire project, we are in this access priority, so innovation. We built this project with different participant partners and also with some associated partners of the project. You can have some here the link if you need some information about the Interreg Northwest Europe program. You can find also on the websites all information about the approved project and also information on our project Hi-Ecowire. So here I would like to show you a project overview of Hi-Ecowire project. So the lead partners of the project is, so we are lead partners, is Materia Nova. The duration of the project is 42 months. We start the project on April 2020 and we will end the project on October 2023. So as I said, the program priority is innovation, axis number 1. And for the priority specific objective is SO1 is to enhance innovation, performances and of enterprises through the Northwest Europe region. For the budget, we have a total budget of ERDF about 2.3 million euro, and the total budget of the project is about 3.9 million euro. So this is the project overview. So as we introduced, we are working on development of a new magnet wire, or we call it also winding wire or enameled wire. So it is simply insulated electrical conductor, usually is copper or aluminium, on which we have we applied enamel varnish as insulated materials, and is used in motors, transformers, and also in different electromagnetic equipment. For our project, we focused the development and application in the electrical motors and also in turbine generator, wind turbine generator application. We can find different application of magnet wire in different fields. So as Geoffroy introduced to you, in e-mobility application, in automotive, in also drive systems, energy transmission, and also in renewable energy. This is the annual production of the magnet wire in the Northwest Europe area is about 120,000 tons per year. And as Geoffroy introduced it in the first part, the demand of the protection of magnet wire is growing year after year because of the ecological transition and also for electrification of vehicles and for transport application. So here is the production process of magnet wire in industrial scale. So we can see here on these images the first step for this the different steps for the production of magnet wire. So here we have the wire drawing. The wire is passed in this annealing systems to for surface preparation to remove any contamination from the copper wire before the enamel coatings. So in this part we have the enamel varnish or the enamel coating that will be applied on the wire, and then we pass the copper pass or the wire pass in this carrying system for polymerization of the polymeric varnish, and also to remove all the solvents present in these steps. And we can make different passes to control the thickness of the enamel coatings on the wires. And then in the end, we can have some addition of lubricants to give more mechanical and durability of the enamel and for more protection. And then in the end, we have the winding wire in this last step. So this is the protection process. And for the actual situation, for the production of magnet wire, we use a generally polymeric enamel varnish in solvents. We have different chemistry for this production of magnet wire, but the performances of the actual situation of the actual products need to be improved, and especially for thermal resistance, efficiency, energy consumption, and so on. And also, as we introduced, the current technology use a huge amount of solvents used in varnish, and these solvents need to be burned during the process. So for Hi-Ecowire project, we propose innovative process based on soft chemistry, based on sol gel technology, and also in a polymeric extrusion process. So the target or the objective of the project is, of course, to increase the thermal resistance of the new enamels from 240 degrees Celsius to about 300 degrees Celsius. And by increasing this thermal class, we improve the materials, and also we improve the efficiency of the electrical motors by about 20 to 30% compared to the current situation. And we have also a challenge from the point of view of ecological aspect. We will reduce, by using polymeric extrusion, we will reduce the huge amount of solvents that is used actually in the varnish for the the production actually. So for this project, we fixed different outputs that we need to reach in the end of the project. So first, development of products, enamels based on sol gel chemistry as a primer, and also in polymers by using extrusion. The second output is the development of the process, first on a laboratory scale and also on the industrial scale. And after that, we have the fixed integration of the new enamel wires in electrical motors and also in wind turbine generators. And also we fixed a WP for communication and dissemination of the new technology on the results in the different region of the Northwest Europe area and also over there. We fixed also different steps to reach the objective and also the outputs. I will show you the different steps that we put in evidence, that we put in the project for reach our objectives. So the first steps is the development of new materials, so based on sol gel and polymer chemistry. Second step, development of the process for the application for the new production of magnet wire, and also next last step, validation of the new materials and its integration into electrical motors. For the first step, for material development of the new enamel wires, we have to develop a sol gel primer at laboratory scale and also at larger scale application. We have to choose the best chemistry to have a good adhesion of the sol gel on the copper substrate, and also we have to choose specific chemistry with some functional group here to be compatible with the polymer that will be applied as dielectric materials on the sol gel coatings after the application of sol gel. So we have to control different parameters. So we need to control the solvents to be used in the sol gel primer synthesis. We will focus our research on ecological solvents. We have also to study the stability of the sol, and we have to control the application of the process to have a good adhesion, and also different parameters on this first step for sol gel primer development. For the second point, we have to develop polymer composites using extrusion at high temperature. We have to study the compatibility of the sol gel primer with these polymers. We need also to have a good adhesion tests and different characterization, mainly mechanical, thermal, and electrical analysis. Now, next step for the development of the project is based on it will be focused on the process development of magnet wire. We have to control at laboratory scale development, so application characterization using a small enameling machine linked with extrusion heat. This is at laboratory scale, and also the same work but with at large scale development, so a huge or large scale extrusion enameling machine at industrial scale. This is both for a process. So at laboratory scale, the work will be done between University of Artois, NewTech for the work relates to the extrusion machine, and also with Green Isolation International. And for the steps at industrial scale with the extrusion element machine, the work will be shared between NewTech and Hi-Ecowire. And last step for validation of the new materials and its integration in motors will be carried out with end users. So for automotive application, work will be done with jumeaux électriques, and for the generator for wind turbine, the work will be done with Cadieux Energy, and I will show you these steps just later. In the end, we have a process for validation of the performances and characterization, and this work will be shared with INEM institutes in University of Islingen. This is the thermal testing will be installed by INEM. Electrical model development by University of Galway in Ireland. And also we have a study of life cycle analysis and technico-economical assessment evaluation. The work will be made by Materia Nova and also with help of all partners. So now I will show you all the partners of the project and also their role. Now we have research and institutes. We have also industrial for chemistry, process, and magnet wire production. And we have also industry as end users. So I will show you all I will present to you all the partners and also their specific role in this project. So we can start by Materia Nova. We are located in Belgium. We are research center in innovation materials. So our mission is to carry out advanced study on behalf of large companies and to promote technology transfer between the fundamental research and industrial worlds. As I said, we are lead partner of the project, and also we are VP leader of communication, management, and also long-term. We will focus our technical work on chemistry of sol-gel varnish and also on the development of polymers and composites and also their compounding. And we will also participate in the work on life cycle analysis study. The University of Artois, donc, sorry, is LS2E, located in France. This is a laboratory specialist on electrotechnic systems, and environmental is located in University of Artois in France. They are specialists on electromagnetic devices, and their role in the project, it will be based mainly on the characterization, such as dielectric test, aging, and also the implementation of a specific test with collaboration with Green Isolates International, which is also located in the same university. So University of Galway in Ireland, the Power Electronic Research Center, they are specialists located in National University of Ireland in Galway. They are specialists in magnets, compounds modeling and design. And the role of NWE Galway in the project is mainly based on the modeling and characterization of the developed new magnet wire. So INEM from Germany is the Institute of Sustainable Energy Technology and Mobility. So they are engaged in different research and knowledge related to transfer of the sustainable and efficiency technology for supply of energy. And their role in the project is mainly mainly focused on the validation, on motors, and also characterization. They will be focused on the thermal testing on the new copper wire in the real motors application. Now, Green Isolates International is SME is located in France at University of Artois. they are specialists in the development of polymeric varnish without solvent, so UV based UV varnish without solvent. And their role in the project is the validation by application on the new prototype line tests, and so application and also some characterization of the new magnet wire. So ISIX is SME, is located in Belgium. It is a young company. It was established as a result of consolidation of synergy and a partnership of both technology and industry level. They are specialists on sol gel development and also the application of sol gel for different industry application. And their role in the project, they will be focused on the development of a sol gel primer and also the scale up of the developed sol gel primer for the project. So NewTech is also SME, is located in Italy. They are partners of our project. They are highly Italian specialized company. They are leader in the market of for the production of insulating machinery. So their role in the project is the manufacturing of the equipment for the test, the trials on the new developed wire. So Hi-Ecowire is considered as an enterprise, is located in Germany. So they belong to the world of magnet wire. They are specialists on magnet wire production, developments for different sectors, such as wind turbine, large transformers, and also e-mobility and traction of motors. And their role in the project is the elaboration of different possibilities for higher the TRL level of the developed magnet wire at laboratory scale. So the developed magnet wire at laboratory scale will be tested and produced at large scale at Hi-Ecowire. CADIO in France is also considered at SME. They are specialists in development of renewable energy, and they are involved in different projects and systems. They are specialists in the improvement of small wind turbine performances, and their role of the project as end user is the validation of the new developed copper wire for in wind turbine generators. And for Jumeau Electric is considered as enterprises, is located also in France. It is a company. This is a company part of French Alt-Ouest Group, and they are specialists in the power conversion and power generation markets. And their role in the project is the validation of the new developed magnet wire in motors, and they will give feedback on the real performances of the new product in electrical rotating machine. So NextMove is also real partners, as Geoffroy presented in the first presentation. Their main role is dissemination and also long-term effects, work related to the long-term effects. Okay, this is the role of partners. This is just a summary on what I presented before. And now we arrive to the long-term effects work and also dissemination. And this part will be presented by my colleague Mireille Polman. Mireille, please, I can give you a hand.
Okay, thank you, Hamid. I will present them, but you will have to click for the slide, you know.
Okay.
So hi everyone, and I'm very glad that there are so many people connected. So what is long-term effects? It's something maybe particular to this type of Interreg project, and in fact they are all the actions that are carried out during the project life to maximize future exploitation opportunities. So they are based on some technical aspects because of the different steps of validation of technologies in different sectors. Some are considered directly in the consortium, but some could be added through some additional validation tests in other sectors than those mainly considered in the project. Certification is also, of course, very important in this field. The idea is not to certify within the project, but to have altogether all the information, the testing, the characterization on the material, on the process that will help and the further certification or standardization at Amit. I saw my face appearing. Okay, so then communication, of course, large communication, dissemination actions, demonstration, workshops are key to bring to the technologies to the companies and to share with them the main results, to give them the opportunity to make some tests, to evaluate coated wires and so on. And this is based on a good network, and that's why we are organizing some of these actions like today, webinars to show the project scope and to invite you then to follow us, and so that you can at any moment of the project life you can interact with us for having more information or participating to some test. So the idea is really to maximize the chances of a large industrialization of the technology in European Union and of course particularly in the Northwest Europe. So Amit, can you go to the next slide, please? Thank you. So the first big step of this this long-term effect work package is to set up a long-term network. And so it's aimed at identifying this network, to have a clear view on all the industries that will cover all the value chain and the different sectors and areas, and of course mainly for SMEs. And we will then we have already had some associated partners in the project. I will explain afterwards a little bit more about that, and they can then bring the information on the project to all their members, which really maximize the chance of communication dissemination of the project. Then we will contact other clusters and associations to complete, I would say, this network. And each partner can, of course, contact some industries to really have at the end a good advisory board, which will be composed of some industries, institutes, associations, certification agencies that will be able to follow the project process, being involved in informal main project results and giving advices on the validation steps. So Amit, can you go to the next? Okay. So here is a brief overview of the consortium of the partners and associated partners. So you can see the partners are there distributed over this sketch, which shows the different areas and geographical areas and the different sectors. So the idea is maybe not to fill any empty square, but anyway to maximize the filling of this. And today we have already some associated partners, which are Skywin, Itrans, the Automotive Alliance, UCR, European Copper Institute. We have Paul Mecatech, and I think didn't forget, and VOM, I forgot VOM. It's not on the. Yes, it's on it for the coating aspect. So you see that we have and for the Netherlands, the RAI. Sorry, sorry, I forgot to mention it. So you see that we have already some associated partners, and I think some of them are connected today. That's very nice, and I hope this bring a good overview of the project to them. So please, Amit, can you go to the next slide? So I will now give some information on the communication activities. That is the basis of this long-term effective work package. So we started communication, and today is one of our communication activity, which is very important, of course, webinars. But there will also be some promotional material. There are digital activities. There is a website and LinkedIn network, and there will be some publications. And all the partners and associated partners will contribute to these communication actions by preparing the communication or just by sharing to their network. So please go to the next slide. Okay, so here I have just some more information on the website. I hope you have already visited it, and you will see it will be completed over time. It gives a project overview. You have all the partners of the project, including contact, so you can have contact with any of them at any time. But you have also a unique email address to contact us, which is Hi-Ecowire@materianova.be, so we can afterwards transfer the email to the how to say more relevant person, depending on what you are asking. The events will be webinars and workshops organized by the consortium, but other events where the project will be presented will be also announced on the website. So please go further. Okay, there is a LinkedIn page dedicated to Hi-Ecowire, so you are of course invited to follow it. So for the moment we have already hundreds of abonnees, so that's not so bad, but we hope to increase it over time. And anytime there will be some events, some communication, participation to a conference or a trade fair, it will be communicated through this through the LinkedIn page. So Amit, you can go. Okay, and concerning the events, I think it's a very important aspect of the project. So there are what we call technology days, and since COVID crisis, most of them were transformed as webinars. That's a pity not to see people, not to have direct discussion. But on the other hand, it's very easy to organize, and it avoids long travel. So the idea at the beginning was to have two technology days, but in fact, while organizing webinars, we can have two webinars a year if we want at some moment, because it's so, well, easier to organize. So we'll see how the situation evolves. We hope, of course, to be able to organize technology days on site, but for general communication on project, webinars works quite well. What is more important to have it on site is to have the workshops and the training courses. So there will be 2 workshops, mainly on new coating technology, so with a communication on more detailed information on the technologies, including demonstration of the industrial plan. So this will be organized on site, of course. And 2 training courses on the sol gel and polymers for wire extrusion with basic information, but also really providing information on technical aspects of this. And one will be organized by ASICS and one by Hi-Ecowire. So Amit, I think it's the end. So thank you for your attention. And if you have any question, I think you could put them on the chat, but you can also now start to ask them directly. Amit, I don't
Please,
see questions.
I can hear you. I know if you have any question, or we can maybe pass to the Solgel technology presentation.
Yes, I think you can go ahead.
Okay. So Arno, please, I can give you a hand if you want to share your presentation.
You can see my presentation? Yes,
it's working,
okay.
Yes.
Thank you. So I'm going to present you now the technological focus point. This point concerns the Solgel coatings, or also called hybrid ceramic light coatings, as promising technology for magnet wire. First of all, I'm Arnaud Nicolai. I'm working at Hi-Ecowire Surface Technologies as a scientific expert, and I'm technical project manager. Hi-Ecowire is specialized in the production and the application of hybrid ceramic coatings by the Solgel process. It was established in 2019 as a result of the consolidation of synergy and partnership between Technochim and Ionix.
Arnaud, please,
yes.
if I'm not Arnaud, je pense que c'est figé. Is fixed on the slide number 1. I don't know if it is the same for everyone.
Ok, attends, je regarde. And now?
And now, yes, we can see. Okay, now it's working.
Okay. Yes, donc partnership between Technochim and Ionix. Hi-Ecowire has close links with the Belgian company Technochim, which specializes in the mechanical, chemical, and electrochemical treatment of metal surfaces. Technochim complements Hi-Ecowire works, particularly in terms of the preparation and the pre-treatment of surfaces before the application of the Solgel coatings. Also, Hi-Ecowire works closely with Materia Nova Research Center and the company Ionix, which specializes in high-tech surface coatings. This partnership is based on dynamic collaboration, which enables Hi-Ecowire continuously to introduce innovation in its range of Solgel coatings in response to customer requirements. An efficient consortium also with the University of Mons allow us to transfer new technologies from the labs to the company, and so to propose new Solgel coating on the market. Hi-Ecowire has 2 locations. The first one is located in Guilanguin, in the same building that Technochim. And the second one is located in Mons, on the same area that Ionix and Materia Nova. A building dedicated to research and development of Solgel is shared between Hi-Ecowire and Materia Nova. So what is the Solgel coating? Solgel is a ceramic-based hybrid coatings. It's the abbreviation of solution and gelification or gelation. We will go from a liquid solution, the sol, which will transform through reaction into a gel, and in our case of application, into a coating. Usually, the sol contains precursor, solvent, catalyst, acid or alkaline, and additive, either organic or inorganic. The precursors are often metal alkoxides. Alkoxysilans are the most widely used, but others based on titanium or zirconium also exist. These precursors contain hydrolyzable function, like here etoxy, methoxy, or isopropoxy, and can also contain an organic group to give flexibility or functional properties. For example, in this slide, the vinyl function brings flexibility and hydrophobicity. Thanks to this alkoxy function, hydrolysis and condensation reaction will be able to take place to form a gel with a 3D structure. The hydrolysis reaction consists to replace an alkoxide group by an hydroxyl function, and this hydroxyl function can then react either with another hydroxyl group or with an alkoxide group to form a covalent bond called a siloxane bridge during the condensation step. You can note these steps are generally influenced by several parameters such as pH or temperature. And as you can see in this viscosity versus time diagram, the viscosity will increase slightly until it reaches the gel point. And so in the case of coating application, this is what will allow us to obtain, after complete reticulation, of course, a dense and protective film with siloxane bonds, the adhesion bonds with the substrate, and also the organic function providing specific functionality and flexibility to the coating. The possible method of application for coating can be barcoater or at the industrial scale cold coater, by deep coating, spin coating, or spray coating. And the curing method, the densification method, can also vary. This curing step is necessary in order to obtain the densification of the sol-gel matrix. At ISIX, the curing step is generally carried out under heating. However, UV curable hybrid coatings are currently developed, where a mix of siloxane and polymeric chain are formed. Well, the theoretical point is finished. Now let's talk a bit about Cotix. So Cotix is the sol-gel solution range offered by ISIX. Cotix has various functionalities, such as easy to clean, anti-corrosion, or antimicrobial. It can be transparent or colored. But before to explain some examples of functional properties, here are some key properties of sol-gel. It's necessary to have an excellent adhesion, good flexibility without crack or peeling, and sufficient mechanical resistance against the impact, the scratch, or the abrasions. So Cotix can be used as an anti-fouling, anti-dirtying coatings. First of all, it has easy to clean and anti-fingerprint properties, thanks to its low surface energy. Cotix reduces the visibility of the fingerprint on stainless steel, for example, and it facilitates the cleaning with a simple whip of a cloth. It's also easy to clean for food, cosmetic, or other stains, as can be seen on these titanium samples. Cotix also provide anti-corrosion properties, either a barrier to the external environment, such as oxygen, humidity, or chloride, or also chemical resistance against cleaning and disinfection products, usually used in the pharmaceutical industry. Cotix has been validated as compatible, especially with this list of compounds. The sol gel could also be loaded with corrosion inhibitors to have a self-healing aspect, or it could be used as a paint adhesion promoter. This will be the case in the Hi-Ecowire project, thanks to the addition of special functions. Thanks to this anti-corrosion, chemical resistance, and easy-to-clean properties, Isix obtained an Innovation Award in 2019 at the Contaminexpo Fair for the Cotix easy-to-clean transparent coating. As discussed, this allows better cleanability and maintain a durable aesthetic of stainless steel surfaces. So it will protect stainless steel, will reduce contamination, but also maintenance costs. In addition, colored versions are also available, which, for example, reduce the risk of accident and increase efficiency by color coding in the company. Here are some applications in the pharmaceutical industry. For example, we treat grades and trolleys, and we color the clamps in the pharmaceutical industry. Here in the field of household appliance, Cotix makes it easier to clean food stain and fingerprints. And for example, in the case of urban furniture, it will be protected from pollution like exhaust gases or graffiti. Finally, for the example and properties, sol gel coating can exhibit antimicrobial properties. Isix offers Cotix Active. The antimicrobial properties of Cotix Active are shown to provide high level of effectiveness, more than 99.9% against bacteria, such as Escherichia coli and Staphylococcus aureus, and more than 99% against viruses such as coronavirus. Now let's finish with the Hi-Ecowire project. Ceramic-like sol gel coatings will be developed in Hi-Ecowire to promote adhesion of an extruded polymer coating applied on copper wire for electrical insulation at high temperature. The sol gel layer will have to guarantee a perfect perfect bonding between the metallic substrate and the polymeric layer, while contributing to the electrical insulation and thermal resistant property of the whole layer system. It's important to note here that compared to classical organic varnishes, sol gel coatings show higher thermal resistance and an excellent adhesion on a large number of substrate materials. Moreover, thanks to their dielectrical properties, sol gel coatings can be used for electrical insulation. This property is linked to the coating thickness. There is indeed proportionality between breakdown potential and thickness. However, the ceramic nature of sol gel coatings may limit the thickness and lead to defect and cracks. To avoid cracks and defects, the thickness of the coating, the curing, and the chemical composition of the sol need to be controlled. Increasing the organic fraction of the coating or adding charge are some manners to increase the thickness and so the dielectrical properties. The new magnet wire will find application in motors application for aeronautic, automotive, and wind turbine field. This project will thus lead to innovative application opportunities of the sol gel coating technology. So, as Amit said just before this presentation, ISIX, in collaboration with Materia Nova, will be in charge of the sol gel product development to meet the specifications. And ISIX will also ensure the production of the product for the partner. Thank you. If you have some question or comments.
Thank you, Arnaud.
Thank you, Arnaud.
I don't see questions in the chat. So do not hesitate, and if you do not want to ask them directly, you can write them down in the chat of the Teams. Okay, maybe everything was very, very clear. Or everyone is hungry. The presentations should be made available well after maybe rechecking them with the partners to avoid any confidential content to remain on them. But you will be invited to complete a small survey, satisfaction survey, which is very important for us. And you will receive then the presentation if you complete the survey. So you have some homework to do, but very short. So Geoffroy, I don't know if you want to make some additional comment.
This is okay for me. Thank you, Mireille. Maybe if you have some question, but later, of course, we will let you or mail, and you will be able to ask later. So thank you for your participation, and maybe we can close this webinar.
Okay, thank you so much, Geoffroy. Thank you to all participants and to the speaker also. And from my side is okay also.
Thank you very much to everyone.